record. Okay, great. So I think we can start. Today's lesson will be a continuation on optimization. Um, so here's an optimization question. Given this function f of xy is x times y, maximize it subject to this constraint. So the idea is like this. Let's visualize this question. X squared plus y squared equals 4. That's just a circle of radius 4. And what this question is saying is find the numbers, find the pair x and y, such that x times y is maximum, okay? So probably the minimum will probably be, you know, um, uh, you know, uh, this point here is 4 comma, what point is this? Oh, 0 comma minus 4. So okay, let's try to find the maximum. Okay. So how do we do this? Well, we have this function x times y. We know that the maximum occurs when the derivative is equal to 0. So before I do that, before I set the derivative equal to 0, I need to set this function in terms of a single variable. The way I do that is I can solve. I can say, okay, x squared plus y squared equals 4. That tells me y squared is 4 minus x squared. So y equals 4 minus x squared to the 1/2. Okay, so that tells me x times y is x times 4 minus x squared to the 1/2. All right, and now I just take the derivative of this and set it equal to 0. So let's take d dx of x times 4 minus x squared to the 1/2. And here I'm going to be using the product rule, which tells me that this is f g prime plus g f prime. So let's see, what is this going to be equal to? I know that f is x, f prime is 1, good. G, my g is going to be 4 minus x squared to the 1/2, and my g prime, now I have to do a bit of work. So remember, that's the derivative of the inner times derivative of the outer. Derivative of the inner is minus 2x times, it's derivative of the outer times 1/2, 4 minus x squared to the minus 1/2. And let me just adjust this so you can see it. Okay, good. By the way, if you're watching the recorded lecture, I I think you should watch it at 2 times speed. That's what I typically do, or at least 1.5 speed. Okay, I tend to bluster a lot when I'm on Zoom. I just can't help it. I'm not very good at Zoom. But anyway, so this is minus x times 4 minus x squared to the minus 1/2. Very good. Okay, so this is equal to x times minus x, 4 to the minus x squared to the minus 1/2, plus 4 minus x squared to the 1/2 times 1. And we set that equal to 0. Sorry, this is getting a little messy. Hold on, let me just take this here. Move it here. Okay, so this doesn't look very inviting, does it? You can send me a message in the chat. Or at least I don't think this is very inviting. So I don't necessarily want to do this question this way. What we can do instead is we can use implicit differentiation. So if f of xy is x times y, then the derivative of xy is mm,
X derivative to y dx. No, y dy.
hold on here. F g prime
plus
plus
G
g.
GX. I mean, yeah.
Oh, hold on, wait. Hold on, I made a mistake here. What am I doing here? Um, hmm, hold on, I'm being a little irrational here. Mm, it's just implicit differentiation, but it's not coming out right. Hold on. Hold on. Just f g prime plus g f prime. Okay, good. So this is 1. We set this equal to 0. And then when we solve, we get dy dx equals minus y over x. Okay, fine. Hold on, I think I made a mistake when I typed up this problem. Okay, I think we'll return to this problem. I definitely made a mistake on this. That's why it's not going well. What did I do wrong here? I think I made a mistake in my calculation. Does anyone see the mistake?
I think if you can hear me, I think it's due to the fact that you put dx it's supposed to be x uh
Mm-hmm.
dy dx was it's it's f prime it's f g prime was just 1. I think you might that's the part where and then that would have been y plus y times f wait.
Okay, well, we'll move on to another problem. Just give me a moment here. Um, I'm sorry about that. Let
Because
me
F prime is just one because it's X.
Put 1, yeah.
say it again.
F prime is just one because it is X.
Yeah, I agree, but that's what I did. I said that this is 1.
So I think it's gonna be okay. It's G prime. It's gonna be only Y. That's it.
No, 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 because x is not 1. I'm sorry. So
I mean the
I
derivative
made a
is one.
mistake on this problem. I think I made a mistake here, and I just can't find it. So let's move on to another problem. I'm terribly sorry about that. Just curses. I hate it when that happens. Sorry. Oh, by the way, guys, Shamir, I appreciate that you have your camera on, but it actually slows down my computers considerably. That's why I don't have my camera on. So could you guys, let's just keep the cameras off for today. Sorry about that.
No problem, Professor.
Thank you, Shamir. Okay, so okay, let's see. Okay, there is another way for me to do this question. Let me try this. So this is, you have to be a little clever to do this, but if you maximize the product of two numbers, you also maximize the squares of the two numbers, right? So, or let me say, so that means that x squared, y squared is max. We can do it this way. I think it'll work out better. Okay, so instead of maximizing, x times y, let's maximize x squared, y squared, and see what happens. Okay, well, I know x squared plus y squared equals to 4. So that means that y squared equals 4 minus x squared. And so that means x squared times y squared is equal to x squared times 4 minus x squared. And this is a lot more friendly, which is 4x squared minus x to the fourth. Now we take the derivative and we set it equal to 0. So this is 8x minus 4x cubed equals to 0. I hope I got that right. Now let's solve. 8x minus 4x cubed equals 0. That tells me that x times 8 minus 4x squared equals 0. That tells me that either x equals 0 or 8 minus 4x squared is equal to 0. And we can all see that that means that x squared, actually, let me do it step by step. So 8 equals 4x squared, x squared equals 1/2, x equals square root of 1/2, or square root of 2 over 2. Did I make a mistake? I don't think I did. Okay, so I got two solutions here.
One's negative, isn't it?
Huh?
One is negative, isn't it?
One is negative? You mean plus or
Yeah.
minus?
Yeah.
Yeah.
The square root.
Yeah. That's fine.
Why
So,
is it the half plus or minus as well?
Is
the half plus or minus as well?
What do you mean?
Because it's a square root.
It's the same.
Oh.
Plus or minus square root of 1/2 is the same as square root of 2 over 2, plus or minus square root of 2 over 2. Sorry. Okay. All right. Good. So I got two values here that either x equals 0 or x equals square root of 2 over 2. Well, wait, did I get this right? No, I didn't. Sorry. Nobody caught me. This is actually 2 equals x squared. That's right. So x squared equals plus or minus square root of 2. Okay. Oh, sorry. X equals plus or minus square root of 2. Which one of these is the right answer? Well, let's see. Let's think about it. If x equals 0, so if x equals 0, that implies that y is equal to 4. Why? Because x squared plus y squared equals 4. Oh no, y is equal to 2. 0 squared plus y squared equals 4. So y equals 2. Plus or minus 2. But fine. Either way, 0 times 2 or 0 times minus 2 equals 0. That's not the maximum product. There's another product that we can try. So if x equals square root of 2, plus or minus, it doesn't matter. That means that x squared plus y squared equals 4. Plug this in for x and solve for y. You get 2 equals y squared, 2 plus y squared equals 4. So y squared equals 2, and y is equal to the square root of 2. Okay, now you take this product, x times y is square root of 2 times square root of 2, which is 4. Okay. So the maximum values occur when x equals square root of 2 and y equals square root of 2. And what does that correspond to on the picture? What it's saying is, look, 0, comma 4 and 0, comma minus 4, though that product is minimal, but square root of 2 comma square root of 2, which is a point on this circle, that product is maximal. Does that make sense? Are there any questions? Let me just go back here. Are there any questions? No? Okay. So let's move on to the next question. Just a moment here. Let's do, where is this question that I had prepared for you? Here it is. Just a moment. Okay. A point lies on the parabola y equals x squared. Find the point on the parabola that is closest to 0, comma 2. We've done questions like this before, but I want to jog your memory. It's been a while since we've seen each other. So you've got this parabola here. I always like to draw the picture, right? And then there's the point 0, comma 2. Here's the point 0, comma 2. And I want to know, what is the point on this parabola which is closest to this one? Well, we know that the distance formula is square root of x2 minus x1 squared plus y2 minus y1 squared. So we're trying to minimize this distance. We want to minimize distance. Okay. That means that we want to minimize this expression. So I'll let my x2 be x and my x1 be 0. X minus 0 squared plus y minus 2 squared. Okay. Well, if I minimize the distance, if you minimize the distance, then you minimize the square of the distance. Okay, what does that mean in terms of the picture? If I minimize, so let's say this is the shortest path, right? If this length is the shortest path, then this square is the smallest square, okay? That's the idea. So what we're going to do is we're not actually going to minimize this. We're going to minimize the square of the distance. And we're doing this so that we can avoid calculating with this ugly square root. So this is x squared plus y minus 2 squared. Okay, so I want to minimize this. That means I take the derivative and set it equal to 0. Okay, fine. But there's just one problem, and that's this y. You know, I can only take the derivative with respect to one variable.
Why
So-
is the point given, the 2?
Well, that's the point that we're working with. That's what the question says.
Yeah.
A point lies on the parabola y equals x squared. Find the point on the parabola that is closest to 0, comma 2.
Okay, so y would be that x squared. You would fill in x squared for y.
Hmm?
Put in x squared for y in the formula.
Yeah, that's what we'll do. Exactly. So because I know x squared equals y, I'm gonna, like Shamir says, we're just gonna put that into the formula. So this is x squared plus x squared minus 2 squared. Good. And this is equal to x squared plus x to the fourth minus 4x squared plus 4. So this is x to the fourth minus 3x squared plus 4. Now we're going to take the derivative and set it equal to 0. Okay. So then this becomes, let me go onto a new page, 4x cubed minus 6x equals 0. I'm going to factor out this x. And it looks like things are going to work out pretty nicely. I get that x equals 0, or 4x squared minus 6 equals 0. So from here I get 4x squared equals 6, x squared equals 3 over 2, x equals plus or minus the square root of 3 over 2. Okay. So we have this, and we have this. Okay. So it looks like there are going to be two solutions here. There's definitely no maximum value. There's definitely no longest distance from, let me find the picture. There's definitely no longest distance from 0, 2, right? Because I can just keep getting longer and longer distances. So there's definitely no maximum to this question, but these two will be minimums. Okay? These two will be minimums. So if x equals 0, that tells me that since x squared, y equals x squared, y equals 0. And if x is equal to the square root of 3 over 2, that implies that y is equal to the square of the square root of 3 over 2, which is just square root of 3, which is just 3 over 2. So the points which minimize this distance will be the origin and square root of 3 over 2, comma, 3 over 2.
So what you're trying to say is that there can be more than one point that is closest to
Exactly.
the original point given.
Exactly, exactly.
But then how does that fulfill the question of find the one that's the closest one? If there's two.
Yeah, so that's a great question,
closer.
Shamir. That's a really wonderful question. So here's what the picture looks like. I'm claiming that there are 2 points which are closest, and that these distances are the same. These distances are the same. So this is the point square root of 3 over 2, comma, sorry, square root of 3 over 2, comma, 3 over 2. And this is the point 0, 0. These distances, I know that I didn't draw it correctly. It looks like this one looks like this one is shorter than this one, but if I were to draw it correctly, these distances would be the exact same. Okay. So Shamir, if I'm 5 feet away from you and Daniel is 5 feet away from you, it's not that it isn't that neither of us is closest to you. It's that we're the same distance away from you. And it's the same with these 2 points. These 2 points are the same distance away from 0, 2. Is that clear?
Yes.
Okay. All right. Good. Let's see. This is a good question. I'm going to put it in here. By the way, if you need me to go back to any slides, let me know. Okay, so typically I would have you try this question, but in the interest of time, I'm just gonna do it explicitly, and I'll give you a review sheet with a question like this. All right, so a farmer wants to fence a rectangular garden along a river. The side along the river doesn't need fencing. If the farmer has 100 meters of fencing, what dimensions will maximize the area of the garden? So this is a pretty standard question. So here's a riverbank. Okay, this is a river. and the farmer wants to make a fence. He doesn't need fencing along the riverbank. He wants to make this rectangular fence. So if this is X and this is Y, what is this going to be? What is this third point going to be? Sorry, this third line going to be?
X.
X. Very good. Excellent. Yeah. And we want to maximize this area. What is this area? The area of this garden, of this fence, is going to be X times Y, right? The area is X times Y. We know that for any given rectangle. And there's an additional constraint. The constraint is he has 100 meters of fencing. So that means that the perimeter, this plus this plus this, this plus this plus this, is going to be 100. X plus Y equals 100. Okay. So that tells me that 2x plus y equals 100. Now I want to maximize x times y. Okay, I want to maximize x times y. What I'm going to do is I'm just going to solve this. This is two x minus, so I'm going to solve for x. Or should I solve for y? Would it be easier to solve for y? Maybe we'll solve for y.
I think if you solve for y, it's gonna be easier.
Yeah. So this is y equals 100 minus 2x. Okay. There's multiple ways to do the problem. You could solve for x, but this is easier. Okay, so wherever I see this y, I'm going to put 100 minus 2x. So area is x times y is this. Good. So distributing, we get 100x minus 2x squared. We're going to take the derivative of this guy. From here, the problem basically does itself, right? Okay, so 100 minus 4x equals 0. I can instantly tell that this is just 25. Okay, so if x is equal to 25, let's go back to our picture. X is 25. X is 25. So what does y have to be equal to? Well, I can use my constraint to solve. I know that 2x plus y equals 100. So 2 times 25 plus y is 100. So 50 plus y equals 100. So y equals to 50. So
Professor, where did you get the square root from?
which square
Oh.
root?
Oh, that's square. Never mind. I see it now. I see it now.
Okay. Hold on. Sorry, there's something wrong with my tablet here. So x equals 25. Y is 50. Good. So that's the solution to this problem. By the way, Zoom is kind of, I didn't know this when I started it today, but my Zoom, Hunter or CUNY doesn't pay for Zoom any longer. So I only have 40 minutes. So our lecture is only going to be about 40 minutes today. But okay, we have time for, I think, one more question.
Professor, do you know where the final is going to be for the department?
Yes, I will make an announcement today.
Okay.
Can you say, do we can see our grades for exam 2 and
Yes,
exam
yes.
3?
You have to. So a lot of you emailed me. I got back to a few of you, but I didn't get back to everybody. I just have a lot of emails to get to. But just immediately after class, if you send me a message right now, I will send you your grade via email. So just ask me and I'll send you your grade over email. I know we took exam 3. I actually have not gotten those yet. I need to grade those soon, and I will. So if you want your exam 2 grade, just send me an email right now and I'll send it to you. Okay?
Okay.
Okay, thank you, Daniel. Just send me an email. All right. A rectangular piece of cardboard, 20 centimeters by 30 centimeters, is to be made into an open top box by cutting equal squares from each corner and folding up the sides. What size squares should be cut to maximize the volume of the box? Okay, so I have this cardboard, which is 20 by 30. Okay. And so that means that this is 60 centimeters squared. And we want to turn this into an open top box. Open top means that there's no lid. Okay. So this is not there. You remove that one. So how many sides are there here? There are 5 sides. Okay. What size squares should be cut to maximize the volume of the box? Okay, well, what's the volume of the box? If this is x, and this is x, and this is x, that means that the volume is x cubed. Okay. The volume is x cubed. And sorry, hold on. So I'm going to cut this thing up into squares, right? So if this is x, and this is x, this is x, this is x, this is x. Okay, into 5 equal squares. And so that means that each one of these is x squared. How many squares will I have? 5. So I know that 5x squared equals to 60. Okay, 5x squared equals to 60. Actually, this is not an optimization problem. I'm sorry. There was a mistake here. Because I only have a few minutes, I think I'm just not going to go over this. Sorry. This was not an optimization problem.
Professor, can you go back 1 slide to the Y50?
1 second. This? Sorry, just give me a moment here. Oh, that is an optimization problem. Curses. I'm very bad at Zoom. I think you guys can tell. I'm not very I get very flustered on this sort of thing. Let me do this one. This one's really quick. We only have a few minutes, so we have about 5 minutes before it kicks me out. A company produces a product with a demand function as follows. So Q is the quantity sold, and P is the price per unit. What quantity Q maximizes the company profit? Well, what's the company profit? So that's going to be the amount that you sell. So profit is the amount that you sell times the price minus the cost. Okay, so we want to maximize this. So so P is the amount that you sell. This is sorry. P is the price. Q is the quantity sold. So this is Q, and this is times P minus the cost, which is C of Q. Okay. But what is P? P in terms of Q is 100 minus 2Q. And what's cost? That's just 20Q. Okay. Simplifying this, we get 100q minus 2q squared minus 20q. So this is, I need to make a new slide here. $80q minus 2q squared. And when we take the derivative, and set it equal to 0, we see that q is equal to 20. So the one that the q that maximizes the profit is 20. They should try to sell 20 of whatever it is they're trying to sell. Is that clear?
Doesn't it say 20Q right there?
What?
It says 20Q already in the
No, that's the cost.
ah. Okay.
So the profit, what's your profit? It's the amount that you sell times the price, right? Minus the cost.
Oh, okay. So if it's 100, you minus the 20, that's how you got 80. And then you just solve for Q.
Okay. All right, so we have about a minute left. I can't do any more, but this is basically, there's only one more problem I wanted to do, and I'll do that tomorrow. But this is basically everything. This is basically everything. Again, I'm sorry that I was a little flustered today. I'm very bad at Zoom. But I think it went all right. You guys seem to understand this material pretty well. And I think with that, we're basically done. The optimization was the last topic. Next, we'll just have our review. And I'll make a review sheet for your upcoming departmental final. Daniel asks, do we need to memorize all materials that we've been learning during this course? You should know everything, Daniel. You should know all knowledge. Okay? So we'll have a review in the next class. It'll be fine. I'll tell you when your final exam is. Okay, thank you.